Hello to all class 10th titans. Hi everyone, how are you all? So welcome back again in one short video of chapter number 1 of your maths, and that is real numbers. So my dear champion, I'm going to complete your entire real numbers in this single video. Everything. I will be teaching you each and every concept today. Okay, I'm not going to skip anything because as per the new CBSE pattern, anything can be asked by CBSE in your exam. And of course, competency questions will be there. So keeping all the things, all the, scenario, all the patterns, all the requirement, that will be ensuring you guys to get at least 95, 97, 98, 99 in mathematics. Okay, so let's begin this video, one short video. And please make sure to sit with your notebook and pen, guys, and try to practice the questions simultaneously along with me, right? So start. Okay, so chapter number 1, one short video of real numbers. Move ahead. So let's have a look to the today's goal. In this video, what we are going to discuss, which topic will be discussed here. And so basically I'm going to teach her, these are the topics we will be discussing about. Introduction to number system, the basic thing about number system, what are number system, how many types of numbers are there. So basic introduction of number system we will be discussing here in this video. And the second point is fundamental theorem of arithmetic. So in short, it is also called FTA, fundamental theorem of arithmetic, which is very important to calculate HCF and LCM. So this is very important. Once you understand the concept of fundamental theorem of arithmetic, you guys will be able to write the prime factor. You can represent any integer, any number in the form of their product of their prime factors, right? Okay, now after doing this, because I have already told you, on the basis of this fundamental theorem of arithmetic, we will be solving HCF and LCM and relationship between them. So we will be calculating the HCF and LCM between 2, 3, 4 and more integers using this theorem. So this is very important. This theorem is important for this. Okay, so we are going to talk about all these things. And now the most important and favorite topic for all of the students. Sir, you are not right. Not favorite, sir. We have a lot of, we have different kind of phobia from this particular portion, word problem question. Sir, it genuinely scared us. Yeah, I know, my dear champion, with majority of the student, this is the problem to solve the word problem question. They feel, they take this particular topic as a challenge. I know there will be little bit confusing things, but yeah, questions are very simple. In most of the question, you have to calculate HCF and LCM if the word problem question is there from real numbers. Okay, so we are going to talk about this, and this is important as per the CBSE examination point of view. Proof of irrationality. If I ask you, prove root 5 is an irrational number, prove root 11 is irrational number, prove root 3 is an irrational number. We all know these are the irrational numbers, but how to prove mathematically? This is the question, right? So these are the topics that we are going to discuss, and your entire real numbers will be covered in these 5 topics, points. Okay, so without wasting a moment, let's begin with first introductory part, real numbers. What are called real numbers? So please understand, everyone. So in mathematics, basically in mathematics, there are 2 types of numbers. Please focus. There are 2 types of numbers, champions. First is a real number. Real numbers, this is the first. And one more is complex numbers. Complex numbers. Please understand both first, then I will be moving to this diagram. Okay, so first understand real numbers and complex numbers. Basically all the numbers that whose existence is possible in maths, the numbers which can be represented on number line, such numbers are called real numbers. So whether the number is rational or irrational, we can represent the number on number line. But if we talk about complex numbers, so complex numbers are those numbers whose existence is imaginary. We use an imaginary term when we represent complex number. You guys will be studying complex number in the next class. In class 11th, there is a chapter in maths, and the separate chapter is there, complex numbers. One particular dedicated chapter is there for complex numbers. But in class 10th, Just I'm giving you a little bit picture of this, just normal definition. Okay, so real numbers, the numbers whose existence is possible, which can be represented on number line. So real number contain everything. The numbers whose existence is possible, which can be represented on number line. So if we talk about real numbers, so first real numbers is categorized into two groups. One is rational numbers and other is irrational numbers. What is rational numbers? So numbers, the numbers which can be written in the form of p by q, where q should not be equal to 0. Any number which can be represented in the form of p by q, it means in the form of fraction where denominator should not be equal to 0. But if we talk about irrational numbers, so the numbers which cannot be represented in p by q form, such numbers are called irrational number. For example, root 5. Root 5 can't be written in form of p by q. Why? Listen, champion. When you calculate the value of root 5, it comes as 2.23 and something. You can check the third place of decimal, 60 something is there. What happening? Some technical problem. Just a second, everyone. Just a second, guys. Perfect. Okay. So now, my dear champion, what I was telling you, yeah, irrational numbers. So if you write the value of root 5 will be equal to 2.23 60679. Can you see here after decimal how is the repetition? Repetition is very unsystematic. Repetition is uncluttered. Repetition is not in rhythm. Repetition is very disturbed. Sometime 2 is coming, then 3, then 6, 0, 6. So repetition is not perfect. The repetition is not in standard form. So such repetition is called non-terminating, non-repeating decimals. And my dear champion, non-terminating, non-repeating decimal can't be written in the form of p by q. Please keep it in mind. And if it can't be written in form of p by q, it indicates that it has to be irrational number. But root 5 can be represented on number line. Yes, my dear champion, it can be represented. It can be represented on number line. Yes, this is true. We can represent root 5 on number line. You might have studied already in class 9th. So its existence is possible because 2.23 is having some value. 2.23 is having some value. It has some potential. Yeah, its existence is possible. And we can represent root 5 on number line. So whether the number is rational or irrational, they can be represented on number line. It means their existence can be visible. Their existence will be observable. So the numbers whose existence are observable. Come on, yaar. The numbers whose existence is observable. Such numbers are called real numbers, real. And the numbers whose existence is not observable, I mean the numbers which is imaginary, we have to imagine, something is there. Such numbers are called complex numbers. For example, under root -7. This is not possible in mathematics. A number can't be negative under root. But to make the modified form of mathematics, to make the topic broad in mathematics, we have used a very parameter, very systematic form, very powerful terminology which is called iota. So whenever a number is in negative but it is in under root, we can represent that numbers in the form of iota, and this iota is called in mathematics imaginary part. And to call this I, we can say iota. So basically we'll be studying this number. Let me tell you, this is the format a plus ib. This is the complex number format. A is the real part and ib is the complex part, because I is the iota there. So minus root 7 is not observable. Its existence is not possible. But still we study in mathematics. keeping root minus 7 in the category of complex numbers. So there are two type of numbers. I hope you are getting my point. But don't focus on this. Don't get confused, champions. You will be studying these things in the higher standard. Let me erase this. Otherwise, you will be getting confused. Okay. I hope this is clear to you all. So here, presently, we are discussing here complex numbers, real numbers. So these are the real numbers. So both rational and irrational numbers comes up in real numbers. Okay. Now irrational number has just stopped here. Irrational number means the number which can not be written in the form of p by q. But rational number has a little more broad, structure. So if we talk about the structure of rational numbers, so rational numbers, it can be non-integer rational number and it can be integer also. Okay, so non-integer rational numbers, don't take tension about this. I'll be talking about this ahead. Okay, so this is the integer here. Can you see integer rational number is represented as capital Q and integer is represented as capital Z. Now integer has categorized into two parts. Integer means whole number, the complete whole number comes up, and whole number is categorized into two parts, which is 0 and natural number. We all know natural number starts from 1, 2, 3, 4, 5 and so on, and whole number means including 0. Same numbers will be counted but including 0. So this will be and so on till infinity. So including 0 will become this. So both comes in whole number category. Natural number including 0 will give you whole number. Negative numbers means what? -4, -3, -2, -1, 0, 1, 2, 3. These are negative number. Okay, so please erase this positive because we are talking about negative numbers, so 0 will not come. So these are the negative integers. So this is negative integers, and here this is the positive integer. This is basically positive integers. So in positive integers, whole number will come up, and whole number means the combination of all natural number including 0, right? So this is positive integers. Okay, now this is rational number, non-integer rational number. So rational number in the form of p, 2 by 3, 4 by 5, so 4 by 7. These are the non-integer, because integer must be in whole form. Whether it is in negative or positive, it should be whole number. But if it is in fraction form, so this is called non-integer, because 2 by 3 is not integer, 4 by 5 is not integer, 4 by 7 is not integer. Integer means whole number, whether it is negative, positive or 0. It should be whole form, simple number, not fraction. If it is in fraction, so it will become non-integer, but it is a rational number because they all can be written in form of p by q. This entire can be written in form of p by q. You can pick any number. For example, take a whole number. So for example, I'm taking a whole number, any whole number. Select a whole number. So my dear champion, for example, I'm selecting a whole number as 7, only 7. So my dear, 7 can be written as 7 by 1. So here it has become in the form of p by q. So this is a rational number. Now non-integer means what? What do you understand by non-integer? My champions, non-integer means what? Non-integer means already in fraction form, So this is example. For example, 3 by 4, 11 by 5. They all are non-integer rational number. I hope you guys are getting my point. Clear everyone? Moving ahead. So let's do few question here. Look at the question, champions. So the first question is, are the following statements true or false? Give reason for your answer. Okay, so we have to mention the reason also, and we have to identify whether the given questions are true or false. So look at the first question. Every whole number is a natural number. So do one thing. Write down here whole number. So whole number is 0, 1, 2, 3, 4 and so on. Every whole number a natural number. Now natural number. Natural number starts from 1, 2, 3, 4 and so on. Look at the first question. I'm solving here first question. Every whole number is a natural number. Look, every whole number means we have to include 0 also. Whole number means 0 will also be counted. But the question is, every whole number is a natural number. No, 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 no. Because whole number contains 0 also. But in natural number, 0 is not there. Natural number starts from 1. But here question is saying every whole number is a natural number, which is obviously false. Not true. If the question would have become, if the question would be like, every natural number is a whole number, this is correct. Every natural number is a whole number because all these numbers are present here also. But all these numbers are not present here. So this is false. Correct everyone? First question false. Moving to second question. Look at the second question. So first is false. Second question. Look at the second question everyone. Every integer is a rational number. Yes. This is correct. Every integer is a rational number. You can take any number. For example, minus 3. Minus 3 is an integer. Yes. Minus 3 can be written as minus 3 by 1. So this is a rational number. Yes, rational number can be in negative form also. If you might be getting confused, my dear champion. So negative fraction is also a rational number. Yes, negative fraction is also a rational number. If you take 0 is an integer. So 0 can be written as 0 by 5, 0 by 6, 0 by any number. And what is the condition for rational number? Condition for rational number. What is the condition for rational number? So the condition for rational number is the number can be written in the form of p by q, where q should not be equal to 0. So q is not equal to 0 because q is a number here. So if you take any number positive integer, so 2 by 1 can be written as, or 2 can also be, we can calculate 12 by 6. 12 by 6 is also equal to 2. So 2 is also. So whether negative integer is there, 0 is there, or positive integer is there, all can be written in the form of p by q. So all are rational number. So this is absolutely true. Okay, moving to third question. Every rational number is an integer. Wow. Every rational number is an integer. Not at all. For example, let's take a rational number 7 by 5. 7 by 5 is a rational number, but it is not an integer because integers are, these are the integers 0, 1, 2, 3, 4 and so on, minus 1, minus 2, minus 3, minus 4. 7 by 5, where is 7 by 5? These are the integers. Integers are not in decimal. Some student might be thinking, so 7 by 5 we can calculate in decimal and decimal is present there. No, we are talking about rational number. So keep that as it is. I hope this is clear to you all. So every whole number is a natural number, false. Every integer is a rational number, correct. And every rational number is an integer, it is not possible. False, true, false. Can I? Okay, is it clear everyone? False, true, false. False, true, false. Every rational number can't be integer. Moving ahead. Okay. So now let's talk about composite numbers. So composite number, look at the question number 1. Explain why this and this are composite number. So first understand few numbers, then we will be doing this question. So my dear champion, please understand few numbers. So let me teach you first prime numbers. Prime numbers. Please understand everyone. Prime numbers. So prime numbers are those numbers which are having factors, only 2 factors. They can be divided by only 2 numbers, 1 and itself. The numbers which are having only 2 factors, 1 and itself. So the numbers, definition I'm writing here, the numbers are having only 2 factors. Only 2 factors, 1 and itself, number itself. The numbers are having only two factors, 1 and itself. Such numbers are called prime numbers. For example, don't take tension. Your Sonu Sir is here. For example, 5. If I ask you, which number can divide 5? So 5 can be divided by only two numbers, 1 and itself. Yes, 5 can be divided by 1, so the result will be 5. And 5 can be divided by 5, so result will be here 1. So only two possibility, 5 can be divided by 1 and 5 can be divided by 5, the result will be a whole number. Don't, my dear champion, if anyone of you might be thinking, sir, 5 can be divided by 2 also. My dear, so the result will be decimal. We are not talking about decimal. We want perfect division. The remainder should be 0. Here the remainder will not be equal to 0. Here the remainder will be 0, but the result quotient is 2.5. Right? For example, let me show you. When you divide 5 by 2, so 2 to the 4, look at the remainder. Remainder we have as 1. Remainder we have is equal to 1. So 5 can be written as 2 into 2, 2 to the 4 plus 1, 2 to the 4 plus 1. This is not 0 according to Euclid's lemma. A is equal to BQ plus R. Remainder is not equal to 0. We are getting 2.5 decimal. So my dear champion, 5 is perfectly divisible by only two numbers, 1 and itself. Perfectly dividing. We are talking about perfectly divisible. No any number can divide 5 perfectly except 1 and 5 itself. So my dear champion, this 5 is called what? Prime number. For example, this was the example number 1, and let's say example number 2. My dear champion, if I ask you 37, now tell me, how many numbers can divide 37? How many numbers can divide 37? So 37 can be divided by 1 and itself, 37 itself. There is no any other number which can divide 37 except 1 in itself. So 37 can be divided by 1 perfectly, so the result will be 37. And 37 can be divided by 37, so the result will be perfect 1. So such numbers are called prime numbers. 5, 3, 11, 23, 29, 31, so many prime numbers are there. But you might be getting confused about 1. Sir, why you are not bringing 1? So my dear champion, please note this. Please note this. Note 1 is neither prime nor composite. Please champion. 1 is, this is the exception with 1. 1 is neither prime nor composite. Now, listen my champions carefully. If you guys have understood prime numbers, so the numbers which are having only two factor 1 in itself. So what will be composite number? Composite number is just opposite of this. So the numbers which will be having so many factors, the numbers that can be divided by so many numbers, apart from 1 in itself, there will be so many, prime factors. So many factors will be there. So such numbers are called composite numbers. But if only two factors are there, that is prime numbers. I hope this is clear to you all. Okay, so let's move ahead to the composite number. Now let's talk about composite numbers. Okay, composite numbers. So simple, that just opposite of this. How many factors these numbers have? These numbers have only 1 in itself. Now composite number will be having so many factors. So many factors. Apart from 1 in itself, so many factors will be there. I mean, more than 2 factors will be there. So my dear champion, what will be the definition? So let's write the definitions. the numbers which have more than two factors as one and itself. So the numbers which have more than two factors. So the numbers which are having one in itself factor, but apart from one in itself, there will be so many other factors. For example, so the first composite number starts from 4. So I'm taking the example number 4. 4. Now look at the champion. Look at here. 4 can be divided by 1. The result will be 4. Perfectly divisible, I'm asking. 4 can be divided by 2. The result will be 2 and the remainder will be 0. And 4 can be divided by 4 itself. So the result will be 1 and the remainder is 0. How many factors? 1, 2, and this is third. How many factors? 3 factors. So 4 has 3 factors. 1, 2, and 4. 4 can be divided by 1 also, 4 can be divided by 2 also, and 4 can be divided by itself 4 also. Before 4, there are 3 numbers. 1, but we know 1 is neither prime nor composite. Then 2, so 2 is prime number because 2 can be divided by 1 itself and 2. So which is the first prime number? The first prime number is 2. 3 is also prime number. But 4 is composite number. So first composite number is 4. First prime number is 2. I hope you are getting my point. Okay, now tell me 21. 21 is prime or composite? Now check how many numbers can divide 21. By how many numbers 21 can be divided? Now check it once. So my dear champion, first evergreen, 21 can be divided by 21. Now 21 can be divided by 3 also. The result will be 7. Now 21 can be divided by 7 also. The result will be 3. Now 21 can be divided by 21 also. So result will be 1. So 21 has 4 factors. 1, 3, 7 and 21. So this is called composite number. 21 is also composite number because 21 has 1 is there, 21 is there. But apart from these two more factors are there. In 4, 1 is there, 4 is there. This is the identity of prime number. But 2 is also there. So that's why 4 has become composite number. I hope this is clear to you all. Clear everyone? So the numbers which are having more than 2 factors as one in itself. More than 2 factors. This will be there with every number. This will be there every number. But if the factors are more than 2 factors, these are the 2 factors. These are the 2. But we are talking about more than these 2 factors. Or we can also write the number which is having more factors apart from more factors other than 1 in itself. Okay. My dear champion, if this line is little confusing for you, so you can write this: the numbers which have more factors, okay, other than 1 in itself. You can write this definition: the numbers which have more factors other than 1 in itself. So except 1 in itself, there will be so more factors. Such numbers are called composite numbers. So please write in your copy this important note. First prime number is what? First prime number. My dear champion, first prime number is 1. Okay, this is n. Okay, here this is n. First prime number is what? 1. And first composite number. First composite number is 4. So please keep this information in your mind. First prime number is 2. First prime number is what I am writing. First prime number is 2. This is 2 champions because 1 is neither prime nor composite. So first prime number is 2 and the first composite number is 4 and 1 is neither prime nor composite. Please take a screenshot. Everyone, this is very important. Okay, clear everyone? Clear everyone? Okay. Now moving ahead, so let's do this question. So I hope I need to erase this everything. I hope you guys have already taken the screenshot because I'm erasing this. Okay. Now let's do this question. Explain why this number 5 into 11 into 13 plus 13. So this is plus sign. So this is one family and this is one family. Okay. And this number 6 into 5 into 4 into 3 into 2. So this is a single family here till here. And this is another family. Okay. So there are two numbers given we have and we have to explain why these are composite numbers. So let me show you. So look at the first number. I am doing the solution here. Please everyone focus. So can you see the first question? First number 5 into 11 into 13 plus 13. This is plus sign. So my dear champion, if this is plus sign, so this is a single family, all the numbers, and this is the second family. And operation is plus. So can't we take 13 as common because 13 is present in here also or here also. So we can take 13 as common. So let's take 13 as common. So I'm taking 13 common. So we have 5 into 11 and this will be plus 1. Now solve the bracket. So this is 11 5 is 55. 55 plus 1 will be 56. Now write this number in the form of prime factor of this 56. So 2 2 ja 4 2 ja 8 8 7 ja 56. Wow. So this prime factorization can be written as 2. How many 2's are there? 3. So let's select the smaller number 2 to power 3 into 7 into 3 13. Oh my God. After solving this number, we are getting this result. So it indicates that this number, this entire number can be divided by 2. This entire number can be divided. This entire number can be divided by 7 because the prime factors are 2, 7, 13. How many factors are there? 3 factors. Come on. This number can be divided by 2. This number can be divided by 7. This number can be divided by 13. It indicates that this entire number has so many factors. How many factors? So there are 3 factors. There are 3 factors as 2, 7 and 13. So this is a composite number. Yes. And 2 more factors are there. The multiplication, this entire number, and 1 also is there. But we are getting 3 more factors in the form of 2, 7 and 13. So it indicates that it has to be a composite number. This number has to be composite number. Now let's prove this. What is this? Now look at the second number. So let's write the number first. 6 into 5 into 4 into 3 into 2 into 1 plus 5. So this is single family. This is the second family. So can we take 5 as common? Because 5 is present in both the families and plus is the operation here. So on taking 5 common, we have 6 into 4 into 3 into 2, 6 into 4 into 3 into 2 and 5. We have taken 5 as common, so there will be 1. Now solve this number. Can we solve this? So this is 3 to the 6, 6 4 ja 24, 24 into 6. Or we can write also 4 3 ja 12, 12, 12 6 ja 72 and 72 into 2 plus 1. Clear everyone? 4 3 ja 12, 12 6 ja 72, 72 into 1. Now 72 can be multiplied with 2 easily. So this is 7 to the 14 and 2 to the 4 plus 1. So 5 into 1, 45. And 145 can be written as, this number is ending with 5, so it indicates that this 145 will be divisible by 5. Let's take LCM. So on taking LCM of 145, this is 5, 5 to the 5, 9 to 45, and 29 is itself a prime number. So 5 into 29. So 145 can be written as, oh my god, so 5 square 29. Can you see here, my dear champion, on solving this number, we are getting this product of prime factor. So we are getting 5 and 29 as factor. 1 and this entire number is already there as a factor. And we are getting 2 more factor. We are getting 2 more factor. So it indicates that it is also a prime number. So we can write, so the given number, so the given numbers are composite numbers. Composite numbers. I hope this question is clear to you all, everyone. Very easy question. Moving ahead. So let's talk about the most important topic of this chapter, fundamental theorem of arithmetic. So first understand the definition of fundamental theorem of arithmetic. Then I'll be giving you few examples. We'll be doing few demonstration. Don't worry. First, go through the mathematical language information in words. So fundamental theorem of arithmetic says that every composite number can be expressed as a product of primes. Every composite numbers can be expressed as a product of primes, and this factorization is unique. Unique means there will be only one format. There will be no any other format except the single format will be writing there. So that is obviously unique. Just wait little while. Apart from the order in which the prime factors occur, this is called fundamental theorem of arithmetic. Just wait. I know you guys are little confused. Don't worry. See here on screen. If I'm writing 20, 20 is a number. And of course, composite number. So my dear champion, 20 can be written as 2 into 2 to the 4 and 4 5 ja 20. Agree? Everything clear? 20 can be written as 2 into 5. 2 to the 4, 4 5 ja 20. Okay. Now can you see here? 2 is in multiplication with itself 2 times. So we can write 2 to power 2 into 5. So my dear champions, listen. 20 can also be written as 2 square into 5. And can you see? 2 is a prime number. 2 is a prime number. Can you see? 5. 5 is a prime number. 5 is a prime number. 5 cannot be split in more parts. 2 cannot be split in more parts. 2 is 2, 5 is 5. Yeah, 5 can be written as 5 into 1. If you might be thinking, sir, 5 can be written as 5 into 1. 5 into 1 is equal to 5, na? So why you are writing 5 into 1? So 5 is a prime number. So 20 can be expressed in this format. And this is called fundamental theorem of arithmetic. Now if I ask you, do you have any other method? Do you have any other method to represent this 20 in this form? No. Some student might be saying, sir, yes, I can write this as 5 into 2 square. Arey yaar, both are same. 5 into 2 square or 2 square into 5. Oh my god, you are just changing right to left and left to right. No difference. Only one format to represent 20. This is, and that's why this is called, why? This is called unique. Factorization is unique. I hope you are getting my point. So every composite numbers can be expressed as a product, multiply, product of prime, because 2 and 5 are prime. And this factorization is unique. I hope you're getting my point. Sometimes, see, 20 is very smaller number. So this smaller number can directly be written 2 into 2 into 5. But sometime at the place of 20, there will be very big numbers, very big numbers. So for very big numbers, what you need to do? You have to take LCM. For example, if we take LCM of 20, so 2 will cancel this 10 times, 2 will cancel this 5 times, and now the last 5 will be cancelled. So what we are getting? 2 into 2 into 5, same number, 2 into 2 into 5. So for bigger number, you have to take LCM. For example, can you see here? 480 can be written as, 480 is a little larger number. So 2 into 4, 4 to ja 8, 8 to ja 16, 16 to ja 32, 32 3 ja whatever is there, whatever. 32 into 3 will be 5, 3 ja 15, 5 to ja 60, 32 into 5. This is 2 to ja 4 to ja 8 to ja 16 to ja 32, and 32 into 3. This will be 69, and 69 into 5 will be equal to 480. Let's check it once. Oh, sorry. This is what we are getting here. 32 into 3. 32 into, 32 into 63. 32 into 60. 32 into 3 will be 69, 60. 32 into 3. This is 6 now. Why we are writing 96 will be there? Why we are writing? We have just written the number in opposite form. That will be 96. 96 into, just a second. 32 into 3 will be 96. Sometime little confusion. And one silly mistake can lead deduction in marks. So my dear champion, stay very alert as I was making mistakes. So this is 96 and into 5 last number. So 6 5 is 30, carry 3, 9 5 is 45, 3. Wow, same number 48. So how many 2? 1, 2, 3, 4, 5. So it can be written as 2 to the power 5. How many 3? Only 1 3. So this is 3. Only 5 1. So this is called, can you see here? This is called product of its prime, and this whole process is called fundamental theorem of arithmetic. It's called prime factorization of 450. This is called prime factorization. For example, 15. For example, 64. 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. Check it once. 2 to the 4 to the 8 to the 16 to the 32, 32 to the 64. So it can be also written as 2 to power 6. Yes, how many 6? How many 2? 1, 2, 3, 4, 5, 6. So this is called prime factorization of 64. Because 2 is prime number. Here 2 is prime number, 3 is prime number, 5 is prime number. So this entire format is called prime factorization of 480. So this is very important in class 10th to write the prime factorization, because without prime factorization you can't calculate, you can't find LCM and HCF between 2 and more integers. This is very important. Okay, so let's have one more time a short glimpse of fundamental theorem of arithmetic. So basically this is 420. So 420 can be written as 2 into 210. And now can you see this 2 is prime number. Now we cannot split this 2 in more parts. 2 is prime number. Now this is 220. So now 220 can be written as 105 into 2. 105 into 2 is equal to 210. Again, this 2 is a prime number. This 2 is a prime number. So we can't do anything with this 2. We have to keep this as it is. Now 105 can be written as 35 into 3. 35 into 3. Now 3 is prime number. So we can't split 3 in more parts because this is a prime number. But 35 can be written as 7 into 5. 7 into 5 is 35. Now can you see this 7 cannot be split into 2 more parts because 7 is itself a prime number and 5 is itself a prime number. So 420 is equal to 2 into 2 into 3 into 5 into 7. 2 into 2 into 3 into 5 into 7. So it can be written as 2 square into 3 into 5. So this is called prime factor. Prime factorization. Similarly, 272 can be written as 2 into 136. 136 will become can be split into two parts. 62 into 3, 2 is prime number. Now 68 will be splitted out. 34 into, now 34 can be written as 17 into 2. Now 17 can't be split into two parts because 17 is itself a prime number. So these all numbers will go under multiplication. 2 into 2 into 2 into 2 into 17, which is equal to 272. So this is called prime factorization. I hope this is clear to you all. Moving ahead. So let's do few questions here. Express given numbers as a product of its prime numbers. Very easy. So this is here 140. I'm doing here first question. So 140 can be expressed in product of its prime number. How? Without using pen, let's try to solve this question. 14 means what? 14 means 14 into 10. Yes, 14 into 10. 14 into 10. 14 into 10. Now 10 can be written as 2 into 5. 2 into 5. Yeah, 10 is done. Now 2 and 5 can't be split into two more parts. Now 14 is there. So 14 can be written as 2 into 7. We have prime factor. I have splitted 140 first into 14 into 10. Because these two numbers are very known to us. Because we know 14 is equal to 2 into 7. This is equal to 2 into 7. And 10 can be written as 2 into 5. So now we take a smaller number first. So how many 2? 2 square into now 5, now 7. This is the prime factor of 140. You can also follow this method. Clear everyone? Please multiply. 2 to the 4. 4 into 5, 20, and 20 into 7 is 140. This is called prime factorization. This is called product of its prime. Second question. 156. Now, for 156, you have to take LCM. You have to take LCM here. Okay. So, I'm doing here rough work. Here, I'm doing rough work. So, now let's take LCM. Because it was 140. So, 140 can comfortably written 14 into 10. And which is very easy for us to split 14 and 10 into two more parts. 14 can be written as 2 into 7. 10 can be written 2 into 5, which is very easy. But for 156, it is little bit challenging. So what we have to take? We have to take LCM. Let's take LCM. So this is, once digit is even number, so it is confirmed that it can be divided by 2. 2 7 ja, and this is 2 8 ja. Again even number, so 2 3 ja 6, 2 9 ja. Now this is 13, so 13 will go. Now 13 is a prime number, so 13. So this is the prime factor. These are 2 into 2 into 3 into 13. So this is 2 into 2 into 3 into 13. How many 2's are there? 2 times 2 square. This is the prime factorization of second question. Okay, now moving to third question. This is 3825. Oh my god, this is little bigger number. But this is very easy. How? My dear champion, if the ones digit is 5, so it can be divided, it will be divided by 5, confirm, because ones digit, whenever the number is ending with 5, it is confirmed that will be divided by 5. When the number is ending with 5, it will be divided by 5. But we can check for 3 also. 3 can also, I'm telling you, 3 can. So we have to check, because 3 5 is 15 and 5 comes up at that one's position. So let's check it by 3, whether it is dividing by 3 or not. So 3825. Let's check it by 3. So this is 3 1 ja 3. This is 3 2 ja 6. And this is 3 4 ja 12. Oh, no. It is not dividing by 3 because 3825 is there. It is not dividing by 3 because 3 1 ja 3. We have 3 2 ja 6. 6. Yeah, oh my god, this is dividing. Let's check it once again. Okay. So 3 1 ja 3. Cancelled. This is 8. So 3 2 ja 6. 6 is there. But we have 2 also remainder. So 2 will be 22. So 3 7 ja 21 and 1 5. Wow, it is dividing by 3. Yes, it is dividing by 3. We can verify by multiplying. So 5 3 ja 15, 1 7 3 ja 21, 21 2 carry over. 2, 3 to just 6 to 8. Yeah, it is dividing perfectly. Yeah. Now let's check it by again 3. It is dividing or not. So 3 4 ja 12 and 3 2 ja 6 and this is 3. Wow. It can be divided by 425. Now check it by 3. So 3 1 ja 3. No, now it cannot be divided by 3 because 3 1 ja 3, 3 4 ja 12 and 5 can't be divided by 3 fully. But it can be divided by 5 comfortably because the ones digit is 5. So 5 8 ja 40 and this is 2 5 5 ja 25. Right? Now it can be divided by 5. 17 and now it can be divided by 17 itself because 17 is itself a prime number. So 3825 can be written as 3 into 3 into 5 into 5 into 17. So 3 is getting multiplied 2 times. So we can write 3 square. 5 is getting multiplied 2 times. So we can write 5 square and this is 17. And these are the prime factorization. This is called prime factorization. I hope this is question. I mean, these questions are clear to you all. Moving ahead. Okay. So I hope you have done with prime factorization method, factorization theorem of arithmetic, and you have understood what is called prime factorization of any number. Okay, now it's time to calculate HCF and LCM using these things. Whatever we have studied so far, now we are going to implement in the question to calculate LCF and HCF by, can you see, by factorization method. And relationship between LCM and HCF, by the way, let me give you the formula here. The formula is the product of HCF and LCM of any two integer, between any two integer, is equal to the product of the number itself. This is the formula, very powerful formula. Let's assume A and B are two integers. So the product of their HCF and LCM is equal to the product of number themselves. Very important. Very, very important. But to move on this topic, first we have to understand how to calculate HCF and LCM. Then we'll be able to study this. Okay, so let's do. And few questions are there. So moving ahead, HCF and LCM and the relationship between them. So let's discuss this topic first. Just a second, guys. Some technical problem. Just a second, everyone. The screen got free. Yeah. So let's study HCF and LCM and relationship between them. So my dear champion, to understand this particular topic, we require two integers. So I'm taking here two integers. I'm taking question here. Find the HCF and LCM between 40 and 150. This is the question. For example, find the HCF and LCM between 40 and 150, and let me write by which method? Prime factorization method. Using this method. Okay, everyone? By using prime factorization method. So let's solve the question. So everyone, please listen to me carefully. To calculate, to find HCF and LCM of two integers or three integers by using prime factorization method, first we have to write the prime factorization of all the numbers given there. So first is 40. So 40 can be written as, just imagine this is 40. So 40 means what? 10 into 4, right? 10 into 4, and 10 can be written as 2 into 5, and 4 can be written as 2 into 2. 10 into 5, 2 into 2. 10 into 5, 2 into 2, which is very easy, right? So we can write 2 into 2, which is 4, and for 10, this will be 2 into 5. I hope this is clear to you all. So what is the prime factor? 40. The prime factor of 40 is what? How many times? 2? 2 is 2 times, so 3 times. So 2 into 3 and this is 5. I hope this is clear to you all. Now move to 150. Just imagine 150. Some student will start taking LCM, but my student will be writing prime factorization just in mind without using even pen. So this is 150. What does it mean by 150? 150 means 15 into 10. 15 into 10. And what is mean by 15? 15 can be written as 3 into 5 and 10 can be written as 2 into 5. 3 into 5, 2 into 5. 3 into 5 is 15 and 2 into 5 is 10 and 15 into 10 is 150. So these are the basic tricks by which without wasting 2 to 3 minutes, my dear, you can write the prime factors. So 150, just imagine in your mind, 150 is equal to 10 into 50. So 10 can be written as 2 into 5 and 15 can be written as 3 into 5. And now write in proper manner. First take a smaller number and how many times 5? 2 times. Now, my dear champion, there is a very small trick that I usually suggest every student of mine. I every year suggest every student in this particular topic. My dear champion, look at the prime factorization of 40. The prime factors are 2 and 5. And now look at the prime factorization of 150. The prime factorization is 2 into 3 into 5. 2 is there, 2 is here also. 5 is there, 5 is here also. But 3 is missing in the prime factorization of first number. 3 is here, but 3 is not there. So my dear, always imagine that with 0. If a number is absent in any number's prime factors, so that number you guys can write with power 0, because 3 to power 0 is of course equal to 1. Any integer having power 0 is equal to 1, right? So we can imagine 3 into 0. Why I'm telling you this? Because it will be making you very comfort to take the common number. So this is very important to write the number which is present in the in any number's prime factorization, but that is not present in the second number prime factorization. So please write it down with power 0. Okay. Clear everyone? Now let's talk about HCF. First, HCF. What is mean by HCF? First, understand the HCF. Then we will be writing the correct answer from here. First, understand the HCF. So basically, HCF are highest common factor. This is the full form of HCF. Highest common factor. Do you know what is called factor? Factor means the number which can divide this and this, because common is there. First, factor means what? Factor is that number which can divide that number. For example, if I ask you the factor of 4, so the factor of 4 is 1 also, 2 also, 4 also. So these are called factor. But here is common. So common means what? The highest number, the highest value that can divide this also, that can divide also. I'm taking one simple example. I'm taking here simple example. This is 2. I have two numbers, 2 and 4. 2 and 4. And if I ask you, find the HCF of this number. Find the HCF of this pair of numbers, 2 and 4. So if we write the table of 2, 2 1 ja 2, 2 2 ja 4, 2 3 ja 6 and so on. And if we write the table for 4, 4 1 ja 4, 4 2 ja 8, 4 3 ja 12 and so on. This is 2 2 ja 4, 2 ja 6, 3 3 ja 2, 4 ja 8. And this is 4, 4 1 ja 4, 4 2 ja 8, 4, and this is 16. Now, let's understand the HCF. HCF is common factor but highest, and which can divide both. Highest and which can divide both. Are you getting my point? Highest, but it can divide both. So my dear champion, look at the numbers. here, this, write the factor, prime factors, because we are talking about here factor. So what are the factor of 2 and what are the factor of 4? Let me make this question very magical for you. Let me give you the factor. So 2 can be divided by 1, 2 can be divided by 2 also. Only 2 factor. But 4 can be divided by 1, 4 can be divided by 2, and 4 can be divided by 4. Yes, because we are talking about highest common factor. So we don't need to write the table. Table will be written in LCM, because LCM is least common multiple. And multiple means what? Table. When we write the table, that is basically multiple. 2 plus 2, 4, 4 plus 2, 6. This is called multiple. But this is the factor. The factor of 2 is 1 and 2. The factor of 4 is 1, 2, 4. Now, highest common factor, which is common in both? Which is common in both? So, my dear champion, the common number in both is 2. So, HCF will become 2. Because 2 can divide 2 also. And 2 can divide 4 also, and we are looking for the number common factor, highest common factor. I know 1 can also be divide 2, 1 can also divide by 4, but we are looking for highest. Come on yaar, highest common factor. So 2 will be the highest common factor. I hope you are getting my point. So this is called HCF. So I hope you guys have understood it. So let me teach you here simultaneously LCM also. Same number I'm taking. Now I'm asking to you LCM. What is the full form of LCM? LCM is basically least common multiple. This is very important term, champion. Factor and multiple, very important term. Listen, factor means the number which can divide both, common, and multiple means the number which can be divided by both. HCF means the number which can divide both, and LCM means the number which can be divided by this also and this also. So the number should be there in the table of 2, and the number should be in the table of 4 also. Table is called multiple. So let's write the table of 2. I'm teaching you here LCM, guys. So table of 2 will be what? Table of 2. Let me use same color because otherwise you will get confused. So yeah, table of 2 will be what? 2 1 ja 2. 2 1 ja 2. I'm making these topics very easy for you. So table of 2 will be 2 1 ja 2, 2 2 ja 4, 2 3 ja 6, 2 4 ja 8, 2 5 ja 10, 2 6 ja 12, and so on. Now table of 4. 4 1 ja 4, 4 2 ja 8, 4 3 ja 12, 4 4 ja 16, 4 5 ja 20, and so on. Is it clear, everyone? Now we are talking about least, means smallest value. Common, that should be present in both, and multiple means table of this, table of this. So can we please check it once, which number is common, but it should be least. Come on, I'm using red color. Come on. Oh my God, can you see here? 2 is here, but 2 is not here. 4 is here, 4 is here. 8 is there, 8 is also there. 12 is there, 12 is also there. But we are looking for least value. We are looking for least value. Least common multiple. So the least common multiple will be 4. The first number which is coming in the table of both. 4 is present in table of 2. 4 is present in table. Yeah, I agree. 8 is also present. But we are looking forward for least value. So the LCM here, LCM will become 8. The LCM of 2 and 4 will be 8, and the HCF will be 2. So HCF means 2 can divide this and this, and LCM means 8 can divide by this, So LCM is that number which can be divided by the given numbers, and HCF is the number which can divide the given numbers. This is the difference, everyone. I hope Now you guys have understood the difference between LCM and HCF. Now let's do this question here. Okay, so how to find the HCF and LCM between two numbers? So if the number for a smaller number, we can directly use these things. Very easy method. But for bigger number, what we to do? So using prime factorization method. So I'm giving you a very short trick here. Important short trick. Listen everyone. So for HCF, what is the full form of HCF? HCF is basically is equal to highest common factor. So my dear champion, to calculate HCF, always take the smallest power of common number which is present in the prime factor of both. So highest common factor, for highest common factor we have to take the smallest power. Please everyone, just opposite. Smallest power of what? Common factor. So now what will be the smallest power? Let's select 2. So 2 is 2 to power 3 and here 2 to power 1. So which will be considered 2 to power 1 because we are calculating here HCF. Smallest power. Just opposite. For highest, smallest power. But for lowest, least, the greatest power. For LCM, we have to take greatest power. Now select 3. Here 3 is 3 to power 1 and 3 to power 0. That's why I had suggested you to write the missing. If 3 is present here, 3 is not present here. Please make sure to write 3 to power 0 so that you guys can take comfortably common smallest. So 3 to power 0, 3 to power 1, which will be considered 3 to power 0. Right? Prime factor. Smallest. And now 5 to power 1, 5 to power 2, which will be considered 5 to power 1 because we are calculating here HCF. So 2 to power 1 will be 2 and 2 into 5 will be 10. So this is the HCF is 10. Now find out the LCM. So for LCM, we have to take the greatest power. Greatest power of common factor. Greatest power of common factor. So what will be the greatest power? Can you see 2 to power 3 here and 2 to power 1. So which will be considered 2 to power 3. For highest, smallest. For least, greatest power. Just opposite. And now 3 to power 0, 3 to power 1. So which will be considered 3 to power 1. And now 5 to power 1, 5 to power 2, which will be considered 5 to power 2. Now let's solve this. 2 to the 4 to the 8. And this is 2 to the 4 to the 8. 8 into 3 will be 24. And 5 square will be 25. 5 square will be 25. Now multiply. 24 into 25. 24 into 25. So this will be equal to 120. And this will be equal to 48. So 0, 8 to 0, this is 600. So the answer is 600. LCM is 600. Now what do you understand by HCF and LCM? HCF is that number which can divide both. So 10 can divide 40 also. 10 can divide 150 also. And LCM is that number which can be divided by these two. 40 can divide 600. 150 can divide. So this is the first multiple, least common multiple. And this is the first. This is the highest common factor. Highest common factor. I hope this is clear to you all. Clear everyone? Moving ahead. So I hope this is clear to you all. And simultaneously, please understand one more thing. This formula, the product of HCF and LCM of two number is equal to the product of number itself. Let's apply this formula here. Let's prove. So HCF we have is 600 and LCM we have is 10. The first number is 40 and the second number is 150. Now multiply. 600 into 600 into 10 will be 6000. And here 15 4 just 60. 15 4 just 60 and 2 more 0. Oh, verified. Hence verified that the product of HCF and LCM is equal to the product of number itself. Clear everyone? Clear everyone? Moving ahead. Okay, so again one more question. Find the HCF and LCM of, now we have three numbers, three integers. Very easy question, don't worry. So now first write the prime factor of 60. So now the same trick we can use. 60 can be written as 6 into 10. 6 into 10 means 2 into 3. 10 means 2 into 5. So 2 into 3, 2 into 5. 2 into 3, 2 into 5. So this is 2 into 2. We can take 2 altogether. So this will be the prime factor. Check it once. 2 to the 4, 4 to the 12, 12. This is. So we have 2 square into 3 into 5. Okay, now have patience. Find out similarly prime factorization of 84. So 84 can be written as, 84 means 12, 7 is 84. So 12 can be written as 2 into 2 into 3. Getting my point? 84 means 12 into 7. And 12 can be written as 2 into 2 into 3, 2 to the 4, 3 to the 12. So this will be equal to 2 to the 4, 2 to 3 to 12, 12, 7 to 84. So this is equal to 2 square into 3 into 7. Clear everyone? Now, moving ahead, we have 108. Okay, 108 means the ones digit is 8. So it is clear that it can be divided by 2. So when 108 will be divided by 2, it will be 54. And 54 means what? 27 into 2. And 27 means what? 3 into 3 into 2. So I think this will be 2 into 54. And 54 means what? 54 means what? 2 into 27, and 27 means what? 3 into 3 into 3. So this will be 2 into 3 into 3 into 3. Check it once. 3 3 ja 9 3 ja 27, 27 2 ja 54, 54 2 ja 108. This is the way how we can write prime factorization without taking LCM, my dear champion. And how you guys can be improved, how you guys this skill will be improved by practicing. Why I'm able to write this prime factorization without taking LCM? Because due to experience, you know. So when you will be practicing so many questions, you guys will be automatically writing these numbers comfortably without taking LCM. So 2 into 2 will be 2 square, and 3 can be written as 3 cube. Now, one small trick I have given you guys. Please make all the numbers common in everything, in every prime factorization. 5 is here, but 5 is not here, 5 is not here. So we can write 5. Just imagine 5 to power 0, and we can write 5 to power 0. It will be helping you out to take the common value. Now look, 7 is there, but 7 is not here. So we can write 7 to power 0, and this will be 7 to power 0. Now anything remaining, 2 is there, 2 is there, 2 there, 3 is there, 3 is there, 3 is there, 5 is there, 5 is there, 5 is there, 7 is there. Now everything is equal. So now find out the HCF. So HCF will be equal to, I have already given you, HCF is highest common factor, and to calculate the HCF we have to take least common power, smallest power. So for 2, 2 to power 2, 2 to power 2, 2 to power 2, luckily all are same. So 2 to power 2 will be considered. Now 3 to power 1, 3 to power 1, 3 to power 3. So 3 to power 1 will be considered smallest power. 5 to power 1, 5 to power 0, 5 to power 0. So 5 to power 0 will be considered smallest power. Please make sure, because we are calculating a HCF. 7 to power 0, 7 to power 1, 7 to power 0. So 7 to power 0 will be considered. Right everyone? Now HCF will be equal to, calculate 2 to the 4, 4 3 to 12. Answer. This is the HCF. Because 5 to power 0, 7 to power 0 is equal to 1. So 2 to the 4, 4 3 to 12 is answer. Now find out LCM. LCM means least common multiple, and I have already given you short trick to calculate LCM. Take the greatest power of common factor, greatest power. So now select 2. So for 2 to power 2 is here, here 2 to power 2, here 2. So 2 to power 2 will be considered. Now it's time to select 3. So 3 to power 1, 3 to power 1, 3 to power 3. So 3 to power 3 will be considered highest power. For LCM, highest power. Now 5 to power 1, 5 to power 0, 5 to power 0. So 5 to power 1 will be considered. Now 7 to power 0, 7 to power 1, 7 to power 0. So 7 to power 1 will be considered highest power. For LCM, take smallest power. For HCF, take a smallest power. For LCM, take the greatest power. Now solve this. So 2 to the 4, 3 3 9, 3 27, and 7 5 35. Now let's multiply. So I hope this is clear to you. 2 to the 4, 3 3 9, 3 27, 27 into 4. So this will be equal to 35 into 4. Can you please multiply this 27 into 4? So this is 7 4 is 28, 8 carry 2, 4 2 is 8, 8 2 10, 108 into 35. Let's multiply here. 108 into 35, 8 5 is 40. This is 40 and 5 1 is 5, 8 3 is 24. Carry 2, this is 2, 3 1 is 3. So this is 0, 8, 7, 3. So this is, my dear champion, 3 7 8 0. This is the LCM. 3 7 8 0 is the LCM. I hope this question is clear to you, everyone. Very, very easy question, everyone. Clear to all? 3780 is the LCM. Moving ahead. Okay. So yeah, correct. So the question is given here and solution is also given here. So I have solved and solution is also given here. Can you see? Where is the LCM? LCM is 3780. What is our answer? LCM is 3780. Clear, everyone? Moving ahead. Wow, what a question. So we have this number A, and then we have to find out HCF. My dear champion, just imagine I'm giving you rasgulla in plate. Rasgulla, it means the number is already in prime factorization form. So rasgulla is, ready for you, just you need to eat. This is similar to that. So rasgulla is already in the plate and you have to just eat the rasgulla. I mean, you don't calculate, you don't need to find out the prime factorization. It is already given. You have to just write down the HCF. So we know for HCF, we always take the least power. So my dear champion, this is 2 to power 2 and this is 2 to power 3. So which will be considered? 2 to power 2, smallest power. We have to consider a smallest power. Clear, everyone? Of a smallest power of common factor. Smallest power. So smallest power will be 2 to power 2 here also. Now for 3 to power 3, 3 to power 2. So this is 3 to power 2 will be present in both. 5 to power 4 and this is 5 to power 1. So only 5 to power 1 will come. Right? Smallest power. So now calculate. This is 2 2 is 4, 3 3 is 9 and this is 5. 5 4 is 20. 20 into 9 will be 180. This is the answer. 180 is answer. So 180 is the HCF of the given number. Clear, everyone? Clear, everyone? Moving ahead. So, oh my God. Question is given here, solution is given here. So product of the smallest power of each common prime factor, and this is answer is 180. I have already solved. Moving ahead, find the HCF and LCM of 510 and 92 and verify this. Very easy question, yaar. Please, 510. So 510 can be written as, come on, use your brain. 510. 51 means 17 into 3, but 0 is there. So we can imagine 17 into 30. Yes, 17 into 30, and 17 is a prime number, so we cannot break 17 into so more parts. But 30 can be written in the prime factor because 30 is a composite number. So 30 can be written as 2 into 3 into 5. 2 into 3 into 5. 5 3 are 15 to the 30. Very easy question. So my dear champion, this 510 can be written as 2 into, first start with 2. So my dear champion, if we take LCM of 510, this is 2, 2 2 ja 4, 1, 2 5 ja 10, 1 0, 2 5 ja 10. Now 5, 5 5 ja 25, 5 1 ja 5. Now 3, 71. Now 17, 1. So we have prime factor 2 into 3 into 5. First write the smallest number, 5 into 17. Is it clear, everyone? So all are prime number. 2 is also prime number, 3 is also prime number, 5 is also prime number, 17 is also prime number. So 5, 3 to ja 5, 5 5 ja 25, and 3 to ja 6, 6 5 ja 30, 30 into 17 is equal to 510. Right, everyone? Okay. Now 92. So now take LCM for 92. 92, this is, so my dear, this is 46, 2, 23. Now 23, this is 1. Because 23 is itself a prime number. So 92 will come, 46 will be divided by 23, 23 is a prime number. So we have 2 into 2 into 2 into 2 means 2 to power 2. We can directly write 2 to power 2. Is it clear, everyone? We don't need to write this because now you guys are expert. 2 is multiplying with itself. So we can write 2 to power 2 into 23. Clear, everyone? Now find out. So again, using that trick, 5 is there but 5 is not there. 3 is there, 3 is not there. So we can write 3 to power 0. 5 is there, 5 is not there. We can write 5 to power 0. 17 is there, 17 is not there. 17 to power 0. 23 is there but 23 is not there. So 23 to power 0. I hope now every number is similar, identical. I mean, every prime numbers are present in both. 2 is there, 2 is there, 3 is there, 3 is there, 5 is there, 5 is there. Yeah, it is different thing. I know this power is 0, but presence should be there. They should be visible in both prime factorization. Now find out LCM. So LCM is least common multiple. For least, we take the greatest power. So 2 to power 2 will be considered. 3 to power 0, 3 to power 1 will come. 5 to power 1, 5 to power 0, so 5 to power 1 will come. 17 to power 1, 17 to power 0, 17 will come. 23 to power 0, 23 to power 1, so 23 will come. Now solve this. 2 to ja 4, 4 3 ja 12, 12 5 ja 60. 2 to ja 4, 4 3 ja 12, 12 5 ja 60 into 17 into 23. So we have to multiply these numbers. Let's find out HCF first. Now HCF. HCF means highest common factor. So for HCF, we always take the least common power. So 2 to power 1, 2 to power 2. So 2 to power 1 will come. 3 to power 1, 3 to power 0, 3 to power 0 will come. So 3 to power 0 means 1. Let's write it first, no problem. 5 to power 1, 5 to power 0, 5 to power 0 will come. 17 to power 1, 17 to power 0, 17 to power 0 will come. 23 to power 0, 23 to power 1, so 23 to power 0 will come. Least power. So HCF is equal to what? Look, 3 to power 0, 5 to power 0, 17 to power 0 or 23 to power 0, all are 1. So we have only HCF2. This is HCF and this is LCM. Now we have to verify the product of number also. So let's verify. So I'm doing here verification. Verification. So let's multiply HCF into LCM. So this is 60 into 17 into 23 into 2, right? So what will be the number? So 60 into 2 will be 120 into 17 into 23. Let's multiply all the numbers. Let's multiply. Otherwise, we can also do one thing. Now multiplying both the numbers. Numbers are 510 into 20 into 92. Into 92. Okay. So my dear champion, we can do one thing. This 510 can be written as 17 into 30. I hope you guys are agree. And this 92 can be written as, yes, check it once. 4 into 23 is equal to 92. Have patience. 17 into 30 and 4 into 23. Correct, everyone? Okay. Now look, what is this? 30 into 40 is equal to 120. Wow, sir, you are creative. And this is 17 and this is 23. Now everyone, can you observe the product of HCF and LCM is 17 into 120 into 17 into 23, and the product of numbers is 120 into 17. See, you guys can calculate the value also. You guys can calculate the value here also, but it will be taking little bit time. So I have used my creative skills, my mathematics. And if you product these numbers, the result will be there. If product these numbers, the result will be there. The result will be similar. Hence verified. Hence verified. Hence verified. Hence verified. The product of HCF and LCM is equal to the product of number itself. By the way, champion, in board exam, don't follow this because your marks might be deducted in exam. So do one thing, please calculate the number, please multiply 120 into 17 into 13, 23, write the number, and here also multiply all the numbers. Please, yeah, please follow this. Okay, moving ahead. So similarly here also, can you see the multiplication is equal to 46,920. We can write here 46,920. Okay, and this will also give you 46,920. Solution is also given here. Okay, moving ahead. Very easy question, simple. So HCF here is 18 and we have to find LCM. Find LCM and two numbers are given to you. My dear champion, this is very easy now. HCF into LCM is equal to 252 into 594. Right. HCF is 18 here. So 18 into LCM. 18 into LCM is equal to 252 into 594. Now LCM will be equal to 252 into 594. This 18 is in multiplication. When this 18 will go there, it will become in divide form. So look, when 252 into 594 divided by 18, 8316 will come. You guys can divide. Let's say this is 9 to the 18 and this is 156. 9 to the 18 and 156, right everyone? Now you can divide this here. 9 1 ja 9, 9 1 ja 9. This is 18. Yeah, 9 1 ja 9 and this is 9. This is there. Now 14 into 594. 14 into 594. This is 4680. 868316. 8316. You guys can multiply. This is the answer. Well, by the way, we can check now. 4 into 4 is 16. So once digit 6. This is correct. Otherwise, you guys can verify in rough section. 594 into 14. 4 4 ja 16. Carry 1. 9 4 ja 36. 7 37. 7 carry 3. 5 4 ja 20. 23. 4 1 ja 4. 9 1 ja 9. 5 1 ja 5. So this is 6. 7 4 11. Carry 1. 9 3 12. 12 1 13. Carry 1. 5 2 7. This is 8. 8316 is correct answer. And solution is also given here. Moving ahead, okay, the LCM of two numbers is 9 times their HCF. Okay, there is a number. The LCM of two numbers is 9 times their HCF. Okay, so if we imagine HCF as x, so the LCM, this LCM will become 9x. Clear everyone? Because the LCM of two numbers, I don't know the numbers. Let's have patience. I don't know the numbers. But the relation given here is LCM is 9 times of HCF. So I'm assuming HCF as x. So LCM will automatically become 9x. Okay. Now read the question. The sum of LCM and HCF is 500. Very good. So the sum of LCM and HCF, it means that 9x plus x will be equal to 500. Clear everyone? Sum of HCF and LCM now. So this is 10x is equal to 500. So x will be equal to 500 divided by 10. This will be cancelled by 50. 100 cancel. So we have x is equal to 50. And if you have x is equal to 50, it implies that HCF, we have assumed HCF as, so this is HCF 50. First answer. And LCM will be what? 9x. 9x what? 9 into 50. Right, everyone? 9 5 is 45, so this is 450. LCM is equal to 450. HCF is 50 and LCM is 450. Moving ahead, given here, HCF of two number is 50. So we have to find out only HCF. Okay. LCM is not required. Okay. But we have solved here, no problem. Okay. Now let's do your favorite section, word problem of HCF on HCF and LCM. So in word problem question, concept is very important and few questions. So look at the first question here. Look at the first question. Ravi and Shikha drive around a circular sports field. Okay. There is a circular field. Okay. So this is circular field. Okay. Okay. One is Ria here. Ria means R and Sikha. Both are friends, best friends, Ria and Sikha. Drive around a circular sports field. There is a field, circular in shape. Ravi takes, okay, Ravi and Sikha. Ravi takes 16 minutes to take one round. Okay. Ravi is taking how much time? 16 minutes to take one complete round. Ravi is starting from here and in completing one round, he is taking 16 minutes. While Sikha completes the round into 20 minutes. Perfect. Shikha is taking 20 minutes. Okay, this is the scenario. If both start at the same point, their starting point is same, at the same time and go in the same direction. Perfect. Ravi is going in this direction and Sikha is also going in this direction and they're starting from this point. This point is the initial point. Right, everyone? Both are going in the same direction from the same position. After how much time will they meet at the starting point? Come on, yaar. It means we want to calculate the number which is common, which can be divided by this and which can be divided by this, because we want to calculate after how much time will they meet at the starting point. After how much time they will be meeting again. So basically in this question, we are looking forward a number which comes in the multiple of 6, which come in the multiple of 20 and which will be LCM. So find out the LCM here. Yes, my dear champion. So 16 can be written as 2 into 2 to ja 4 to ja 8 to ja 16. So 2 to ja 4. 20 can be written as 2 into 2 to ja 4. 4 5 ja 20. So 2 to power 2 into 5. My dear champion, again same trick. 5 is present here but 5 is not here. So we can take 5 0. Okay, now find out LCM. So I have already told you, champion, to find out LCM we always take the greatest power. So that in 2 the greatest power of 2 will be 2 to power 4. And 5 to power 0, 5 to power 1, 5 to power 1 will be considered. Simple. So 2 to ja 4 to ja 8 into 4. 2 to ja 4 to ja 8 to ja 16. So this is equal to 16 into 5, and 16 into 5 is equal to 80 minutes. This is equal to 80 minutes. 80 minutes. This is the answer. After 80 minutes, they will be meeting again. You can change in minute also. So 80 minutes means what? 80 minutes can be written as 60 minutes is equal to 1 hour. So we can write 1 hour 20 minutes. So after 1 hour 20 minutes, they will be meeting again at the starting point, at this point. So answer is 1 hour 20 minutes. 1 hour is equivalent to 60 minutes. And one more 20 minutes, 60 plus 20 is 80 minutes. Moving ahead. Question is given there. Oh, simple. 80 minutes. Since both Ravi and Sikha move in the same direction and at the same time, the method to find the time when they will be meeting again at the starting point will be LCM. I have already told you. Okay. Write the smallest number which is divisible by both 306 and 657. Write the smallest number smallest number which is divisible by this and this. Come on, yaar. We are not looking for a number which can divide this and this. Otherwise, it would have become HCF. Here we are willing to calculate. We are willing to find the number which can be divided by this and this. So basically here in this question we have to calculate LCM. Find the smallest number which is divisible by this and this. It means that number should be present in the table of this, and that number should be present in table of this, and that will be least common multiple. I hope you guys can calculate. So this is LCM. Answer is given here. So my dear champion, same question. This is the same question, champion. Don't get confused. This question we are solving here. Okay. So look at the solution. 306 can be written as 6 into 51, and 51 can be written as here. 6 can be 3 into 2 is 6, and 51 3 into 7. 657 is equal to 9 into 73, and 9 can be written as 3 into 3, and 73 is itself a prime number, so it cannot split into more parts. Okay, now LCM will be equal to, for LCM we always take the highest power. So for 3 the highest power will be 3 2 square, and for 2 is highest power 2 because 2 is present, 2 is not here, so this is 2 to power 0, and 17 is there but 17 is not there, so 17 to power 0. 73 is there, 73 is not there, 73 power 0. So 2 will come, 3 square will be considered 17, 17 will be considered 73 to power 1, 73 to power 0, so 73 to power 1 will be considered highest power. After multiplying this, we are having this number. So this is that number, this is that number which can be divided by this also or this also. You can verify by dividing the number. Moving ahead. Now let's talk about proof of irrationality. Proof of irrationality. I mean, if I ask you root 5, we know root 5 is a rational number, is an irrational number. Root 5 is an irrational number. But the question is how to prove. Root 5 is an irrational number, but how to prove? This is the question here. So we are going to talk about how to prove. But before doing this question, before doing this, particular topic, we have to understand the co-prime numbers. What are called co-prime numbers? So dear, please focus on co-prime numbers. This is very important for this particular concept. Co-prime numbers. Listen everyone. I've already told you about prime and composite number. Now let's talk about co-prime numbers. So basically, dear students, co-prime numbers are always come in a relation. This is a relation. Co-prime is not a number. It is a relation. Please make sure. Co-prime is not a number. It is a what? A relation. It is a relation. Now, what kind of relation? Listen. Example. For example, if I'm giving you 5 and 11. Now, if I ask you, how many common factors these two numbers have? How many common factors these two numbers have? So the answer will be only 1. There is no any other number except 1 which can divide 5 and which can divide as well as 11. Only 1 is there. There is no any other number. 5 can be divided by 1 and 11 can be divided by 1. So such pairs are called, this pair is called what? Co-prime pairs. I hope you are getting my point. See, 5 can be written as 5 into 1. 11 can be written as 11 into 11. Now if I ask you, what is the highest common factor? That is 1, which is one answer. So co-prime numbers are those numbers whose HCF, co-prime is a relation between two numbers. So co-prime numbers are the pair of numbers which has HCF 1, which is also called greatest common divisor. So we can write GCD. GCD and HCF both are similar. Don't worry. There is no difference between HCF and GCD. Both are same. I hope you are getting my point. Few more example. I'm taking here example number 2. So example number 2 will be, I think, if I'm taking here the pair, so many pairs are there, so many co-prime pairs are there. So for example, 17 into 23. 17 into 23. Now if I ask you which number can divide 17 as well as 23, there is no any other number except 1. There is only one common factor, 1, which can divide 17 as well as 23. So the HCF, the highest common factor of these two numbers is 1. Such numbers, so this pair is a co-prime pairs. Co-prime pair. I hope you guys now understood. You have understood. So co-prime pairs means the number which are having common factor, highest common factor will be 1. You can keep one simple line in your mind. The common factor, co-prime numbers are those numbers whose HCF is 1. 5, 7, 11, 23, 31 and 3, 31 and 3. This is also co-prime pairs. So many pairs are there. I hope you guys have understood. This is very important. Okay, now let's do this question. If you guys have understood this concept now, it will be helping you a lot here in this solution of the question. So let's do prove that root 11 is an irrational number. Everyone know root 11 is a rational number, but we have to prove it mathematically. This is the question. So there is very important method which is called what everyone? Contradiction method. So we are going to use this method here. So now I'm teaching you everyone contradiction method. Please understand what is called contradiction method. Contradiction is the condition when your result, your conclusion and your assumptions both are not matching, both are not properly synchronizing, both are not making proper rhythm to each other. I mean, your conclusion is different thing and your assumption is different thing. Your conclusion, your result is not according to your assumptions. That is called contradiction process, contradiction condition, right? Okay, so to solve this question, to prove any under root number as irrational, we start the solution from assuming the given number as a rational number. So now let's assume I'm doing solution here. Solution. Okay, so the solution will start from assumption. So assume root 11 is a what everyone? A rational number. Okay, and once you have assumed root 11 is a rational number, it means that we can write root 11 as p by q, because we have assumed root 11 is a rational number, so it can be written as p by q form. And here we have to mention, this is very important information, that don't forget to write this line, very important line. You have to write it anyhow. P and q here, P and Q are what everyone? Co-prime pairs. And co-prime pairs means what? They have only one highest common factor, which is 1. P can be divided by 1 and Q can only divided by 1. So they have HCF is equal to 1. If any one of you according to because of pressure, because of tension of your exam, you might be forgetting this line. So you guys can simply write the HCF of P and Q is 1, please. Or you can write HCF is equal to 1. This is also enough, please. But don't forget to write this line. This is very important. Otherwise, your marks will be deducted. Your marks will be deducted. Now, my dear champion, if you have written root 11 is equal to P by Q, now can we do cross multiplication? Cross multiplication. So cross multiplication will look like root 11Q is equal to P. Root 11Q is equal to P. Now squaring both sides. Squaring both sides. So if we square both sides, champion, this will look like 11 Q square is equal to P square. Root will removed. root will be removed. So 11q square is equal to p square. Now this 11 is in multiplication with q square. When this 11 will go right side, it means p square will be dividing by 11. Here p square is divisible by 11. So p is also divisible. P is also divisible by 11. P is also divisible by 11. And what is our assumption? P and Q are co-prime. It means that some error is occurring there. Something is, some error is coming there, because P and Q are co-prime numbers. So P and Q both are having only one factor, which is 1. But what we have proved here, P is also divisible by 11. Now my dear student, after this line, we can write one new family. P is equal to 11 into M. At the place of M, you can write anything. This M is making 11 in product form. So when 11 is in product form, it implies that 11 will go there. So P is divisible by 11. So just after looking at this line, we have written one more new family, which is equation number 1. This is equation number 1, and this will be equation. And you can write direct. You can write bang. Now Q is 11 square and 11. Oh my! Now 11. When now 11 is divisible by 11, violating our. So also. Hence, it is our conclusion. We have, it can't be irrational number. This of P, this root 2. My solution 5 root what given as rational. What? Now take all them by Q 3 minus 3. This rational number square root 3 is square. My dear champion sign. Number be equal. So it is number be equal. It is quantum number. A rational. Now 11 and assumption was and 5. When thank you so much. Solution is given. If you are from start video from start, of course. Thank you exclusively. Divisible by divisible by divisible by ter. Violating our hence also it is our assumption so we have it can't is guys have understood. Yeah. Root 2. What? Given as rash. Not take all minus 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 2q this is number format of root 3 is question number number b equal. So it is contact a rational Ramshak was five for an entire year. Thank you so much from start video board exam channel, of course 9th and 10th students